Hi there, Mr. Sutton here, bringing you the IM326 Part 1 homework solutions on special products and factors. In this one specifically, we're bringing you differences of squares and conjugates. On this problem, we're trying to simplify this set of conjugates. Since we have conjugates, our answer is going to be in the format a squared minus b squared. So we just have to square the two things and stick a minus between them. So we're going to have x squared, and then we'll have minus 11 squared, which means minus 121. To simplify this expression, we have conjugates here, a plus b and a minus b. So our answer is going to be in the format of a squared minus b squared. So for a squared, we're going to square the first term, the x to the 6th. So that's going to be x to the 6 times 2. We multiply the exponents, so x to the 12th. And for b squared, we have to square the 6x to the 4th. 6 squared is 36. X to the 4th squared will be x to the 8th. So this is going to be minus 36x to the 8th. For this one, we're simplifying conjugates, same terms but with a plus and a minus. So the answer is going to be in the format of a squared minus b squared. So a squared, that's just squaring the first thing, the 3x. That's going to be 9x squared. And then for b squared, we have to square the 4. So we're going to end up with minus 4 squared minus 16. For this problem, we're simplifying conjugates, same terms but with a plus and a minus. So our answer is in the format of a squared minus b squared. For a squared, we just have x squared. And for b squared, we're squaring the 6 and subtracting it. So we're going to be subtracting 36. On this problem, we're trying to simplify something in the format of a plus b times a minus b, conjugates. So our answer will have the form of a squared minus b squared. For a squared, we just square this x here, so x squared. And for b squared, we're squaring the 2, so we're going to have x squared minus 4. To simplify these conjugates, basically a plus b times a minus b, we're going to put the answer in the format of a squared minus b squared. So for a squared, we're squaring the 12x. That's going to be 144x squared. And then for b squared, we're going to be squaring the 5, so we're going to have minus 25. To factor this difference of perfect squares, our answer is going to be in the format of a plus b, a minus b. So we need to square root each of these things and put them in a plus minus. Square root of x squared is x. Square root of 121 is 11. So we've got x plus 11 and then x minus 11. For this problem, I see that I have two perfect squares with a minus between them. Therefore, factoring this, I know my answer will be in the format of a plus b, a minus b. So for a, we need the square root of 100x squared. That's going to be 10x. And then for b, I need the square root of 9. That's going to be 3. So we're going to have 10x plus 3 and 10x minus 3. For this problem, we're trying to factor something in the form a squared minus b squared. So that answer will take the form of a plus b, a minus b. So for a, we've got the square root of 36x squared. That's 6x. For b, we have the square root of 1, which is also 1. So we're going to have 6x plus 1 and 6x minus 1. To factor this problem, it helps to recognize that we can take out a common factor in the beginning. Negative 7 and 28, we could take a negative 7 out of both of those. So if we do that, we're left with positive x squared minus 4 inside. And we have to keep going if we can. Now the inside, this is something in the format of a squared minus b squared. So that means the answer for this factorization will have an a plus b, a minus b look to it. So a, that's just going to be the square root of the x squared, so that's just x. And don't forget to bring down that negative 7. So we've got x, and then we have the b value, the square root of 4. That's going to be 2. So this is going to be x plus 2, x minus 2. On this one, we're trying to factor an a squared minus b squared kind of setup. So our answer will have the form of a plus b, a minus b. For a, we have the square root of x squared, which is just x. For b, we have the square root of 81, which is 9. So we've got x plus 9 and x minus 9. On this problem, we're trying to factor x squared plus 1. Now, since this is the sum of two squares rather than the difference, we actually can't factor it at all, and this is a prime expression. For this problem, we're trying to factor things out. I'm not sure what else to do, so I'm going to start with what I always start with when in doubt, which is take out a common factor if you can find one. Now, these are both even numbers, so we know that these are at least divisible by 2, and it looks like we're not going to be able to do much better than that. So let's take out a 2 then. So that'll give us a 25x squared for that first term, and then that'll be minus 64. Now, this is kind of interesting. The stuff inside the parentheses, we've got two perfect squares with a minus between them. So that means that the stuff inside there can be factored into something in the format of a plus b, a minus b. So for the a piece of this, that's just the square root of 25x squared. That's just 5x. So we'll bring down the 2. We've got a 5x, and then the square root of 64 is 8. So we're going to have plus 8, 5x plus 8, and then we'll just have 5x minus 8, a minus b. On this one, we're trying to factor this expression, 16x squared plus 9. Now, this looks like it ought to be in the format a plus b, a minus b, but the key here is that this is a plus in the middle, not a minus. Since we've got that plus there, we know that the sum of two perfect squares cannot be factored, so this one can't be factored at all. This is prime.